Sports Stat students. We are picking up with where we left off on Tuesday, the April 2nd. I know that we had the early dismissal. We had some people missing. So those that did miss, you have a little bit of notes that you've already missed. We're going to go ahead and get back into where we left off. We were talking about the normal distribution. And I do want to get back the data that we were working on. So in your emails, everybody should have their laptops in front of them. Go ahead and find this email. Some of you may still have this up, but go ahead and edit that NBA 23-24, edit that in browser, and get that pulled up. And we had taken the data in column F. This is the height in total inches for these NBA players. And we were looking at that, and we noticed how it had made a normal distribution. So we're going to go through that again. So let's go ahead and also have Statlet up on another tab as well. And we're going to go to the one quantitative variable single group. We'll type in NBA heights 23-24. I don't think we did this in class the other day or yesterday. Let's go ahead and copy our height in total inches, and let's paste that in and get rid of the text. And we'll begin the analysis, and we get this distribution here. And we had talked about how this sort of takes on, it's definitely a symmetric shape that we see on this. And we had talked about how if we were to draw a line or lay it like a blanket over this, it would make approximately a bell-shaped symmetric curve. And that's really what we're studying in this unit. And hopefully today, tomorrow we'll kind of be done with this. And we wrote down the two rules, the two properties about this. We had said that that the distribution, if we got rid of the dots, the distribution itself would just make a curve like this. And so we had drawn that curve. We talked about how it had a mean and a standard deviation, and we had drawn our lines, and we had learned about the empirical rule, the 68, 95, 99.7 rule. Okay. So what we're going to do is we're going to take this and we're going to look at some questions about the distribution. But let's go ahead and let's take these stats here. We're going to use these, and we're going to actually model this in Statlet. So this is where we were headed. I'm going to go ahead and pull up sort of our standards, what we're covering today in today's lesson. All right, so we are in this unit here, the density curves and normal distribution. We had learned about the two symbols mu and sigma here, meaning the population mean and the population standard deviation. And then we learned about that empirical rule, the 68, 95, 99.7 rule for the normal distributions. If you weren't here yesterday, I've actually put on the subs desk a little normal curve that had the letters A through H, and you may want to copy your neighbors, get that taped into your notes, and write down all of those percentages. What we're about to do now is we're going to look at, we're going to create a normal curve in Statlet, so we're going to see how that would work. And then we are going to calculate areas underneath that density curve. Okay. So we're going to go ahead and I'm going to show you guys how to do that. We can keep this up. I don't really want to get rid of this. So let's make a new tab. Okay. And we'll go to Statlet again, and we're going to look here. Okay. So down below in this section called probability, we're going to go to the normal distribution, and we're going to show what this is going to look like, how we can have the Statlet make the normal distribution for us. It can actually draw the one that we drew yesterday by hand. It can draw it for us, which for your assignments, we're going to be snipping those and putting them into like a Word doc So that'll be the assignment that we'll get later. But what goes in here, it's pretty simple. You just need the mean and the standard deviation. And so we had those from our other page. So this is the mean. This is mu, as we learned about that symbol yesterday. And this one is this is the Greek letter S, lowercase s. This is sigma. Okay, so there's our values. So we're just going to type those in. So this is, I had written on our paper 78.5. We're just going to keep that 78.5. And then the other one is 3.2. I'm fine in your work that we do. If you round these, that's fine. Let's go ahead and hit plot distribution. All right. And you'll notice that for those that were here yesterday, this is exactly what we had drawn when we worked, or when we had made ours by hand. We had written all of these little pieces. So we can see this one is the mean. This represents one deviation above. This is one deviation to the left. And this is 2 deviations, 3 deviations, so on and so forth. Okay. So I'm going to type out the things that I want you guys to write. I think that's just easier to do that in real time, so you guys can write along with me like I normally do in class. But we're going to ask a couple questions to go along with this. So I'm going to put this into a Word document and then type alongside it. Also, if you were not here yesterday, then I'm going to ask that you go ahead and draw, like in your notes for this. You'll write NBA 23-24 heights, and then draw like your best version of this. Okay. So I'm going to go ahead and get a Word doc going. Okay, so I've got this set up, and ideally everyone in your notes, you'd have something like this, and we're just going to write out some questions. So this is question 1. Okay. This is question 1. And the reason that this in Staplet is under the probability section is because that's exactly what we're about to answer. We're about to ask what's the probability that we have a particular outcome, and we can use what we learned yesterday to help us out. So first off, you can write this out underneath this, or you've already drawn this if you're here on Tuesday. You can just type, let's actually title this section in our notes before we get started. So we're going to say, what was our standard here? Okay, calculate area under a density curve, or we're actually going to specify that as a normal curve. So let's put that in here. So calculate area under a normal curve. Okay. And so we think about these areas as probabilities. And on our slip of paper that we taped into our note, which is this sheet here, we were able to actually find all the individual probabilities for each and every one of these. And that's going to be very important for us to keep in mind as we go through this. If you weren't here yesterday, you probably want to write down the answers for A through H on there. I'll, of course, be filling this in as I create my questions, and you guys start trying to answer them, just so I can show you how to do it. Okay. So let's create the first question here. We're going to ask, what is the probability that an NBA player from 23-24 season has a height less than 75.3 inches. Okay. And so as we go to answer this question, we are going to end up using this curve to help us out. And so what we're really asking for here is we are looking for an NBA player that's at this there, 75.3 or less. So we're really looking for this area over here to the left. Okay, that's what we're actually looking for. So I'm shading this in, and we want to know what that is. We know the entire shape is is 100%. We talked about that. Like the whole density curve, this normal curve is 100%. But this purple area represents a small proportion of that, a small percentage. Using this, we can help ourselves figure that out. Yesterday, we had identified that area C was 13.5%. Okay. We've learned that B was 2.35%. And A was 0.15%. Okay. And so what I can simply do is just take all three of these areas, because that is what the purple area is right here. It's equal to A, B, and C added together. So I can take those and just simply add them with a calculator. So 13.5 plus 2.35 plus 0.15. Okay. And you'll notice that's 16%. Now, I do want you to think about that. We said that D was 34%. So if I added A, B, and C together, and then D with that, so if I add D to this 16%, because A, B, and C is 16, let's add the 34, I get 50. So we're showing that this normal curve is split symmetrically, 50% to the left, 50% to the right. And it's nice how it works like that. So what we could have done was, to get A, B, and C, we could have taken 50% and just subtracted 34 from it, and it would have got that for us. So in our notes down here, we are going to type 16%, and you may even want to do the areas 0.15% plus 2.35% plus 13.5% equals 16%. So that's kind of how we worked it, but there's a lot of ways that you can go about it using this empirical rule. Okay. So let's try another question. So question 2. Write this with me. What is, I'll scroll it up. What is the probability that an NBA player's height is, let's do greater than 75.3 inches? Okay. So I'm going to ask whoever is streaming this to pause the video. I want everybody to try to get this answer, and then I'll reveal the answer as soon as it's unpaused. Okay, so we are pretty much starting at the same point, except we're going the other direction. We are going this way now. We want all of this area. Now, you could have, my shading is amazing there. You could have, since we know all these areas, we know that A, B, C, and D are going to be the same on the other side. So I'm going to go ahead and fill all these in. So it's just symmetric, and we see how 34, 13.5, 2.35, and 0.15%. I mean, it's just the same on either side. So we could just add up area D, E, F, G, and H, and we would end up with that purple area that I've shaded up here to get our answer. That would work absolutely fine. But we'll notice that, remember in probability, when we learn probability, we have a term. If I highlight this orange region, this is actually what we got for question number 1. We got this one for question number 1. And the orange and the purple area that I have here, they are what we call complements in probability. We did 100% minus the event that we don't want. Okay, so the answer to question 1 is the complement of the question number 2. So what I could do here is I could just take 100%, subtract 16%, which would end up giving me 84% as an answer. Okay. And so that's what a lot of these questions are going to end up looking like. You just use this empirical rule to answer the questions. So on your assignment, it'll say, hey, I want you to use the empirical rule to do this. Okay. but I'll make a separate video explaining what needs to happen on the assignment. Let's go to the next question. All right, so what is the probability? So question 3 here, I'll give you time to catch up writing. So question 3, what is the probability that an NBA player's height is between 72.1 and 88.1 inches? So whoever's streaming, go ahead and pause it and give people time to try to see if they can get these percentages on their own using the empirical rule. Okay, so what we're looking at here is a boundary. We see that there's a lower boundary, which is this 72.1, and there's an upper boundary. And so it's not sort of continuous, it's just between a particular region. So it's 72.1 and 88.1. And so that covers a lot of this. Okay. Now, it's not 95%. It's not 99.7. So I could just use the empirical rule. If it were exactly within these regions of like from D to E, that would be 68. C to F is 95. And then B, this region B all the way to G is 99.7, but that's not really what's happening here. We're kind of going 2 deviations here on this left side, and then we go all the way to the 3rd deviation way over here on the right side. So we know that from, let me draw a line here. If I go from here to here, that's 95%. So we're kind of adding this extra little bit of area there. That's one way to think about it. That might be the best way to think about it. So we know that this region from here to here is 95%. Then what's left over, if we just go to the empirical rule, is the 2.35% there. So if you already kind of thought through that, you did a really good job. It's 95 plus 2.35. So that's 97.35%. So 90. So let me show how I did that down here, the numbers I added. And if you got it a different way, there's nothing wrong with that at all. There's so many ways to go about this, and I'm definitely not going to limit you on how you got that. So 97.35% is the probability that you would pick. Like if we were to randomly pick somebody, or just thinking about this as an overall NBA probability for 23-24, that's the likelihood that they're within that range. It's just it's a lot of them. Okay, that's the majority. Now we're going to take this to the next level. We've had a lot of success so far with this standard. Calculate the area under a density curve. Really, this should be the normal curve. So calculate the area under a normal curve, and we'll just say using the empirical rule. But the empirical rule kind of runs out after a little bit. We're going to explore that here in question 4. What is the probability that an NBA player is, and we're going to, let's just say this, is greater than 77 inches tall? Okay. So 77 inches tall, that's 6'5", I believe. So we're saying, what's the probability that the NBA player is greater than 77 inches tall? Okay. Now, if you look at this, and let me erase all my writing here. If you look at this, this is something that you'll notice quickly. If we have to estimate where it is, it's probably about here. That's probably where 77 is. And we want this area over here to the right. But the empirical rule doesn't really help us. This empirical, the 68, 95, 997 rule doesn't really apply to this scenario. And so what we're going to learn, we're going to go to Stapplet now and see how that tool can help us with answering this. Okay, and the standard that we're going to be looking at is using what's called a normal cumulative density function. Okay, a normal cumulative density function. And we're going to go ahead and write this down in our notes here. If the value does not fall exactly on a standard deviation, use Stapplet to help with the calculation. So we're getting some technology involved here, and this actually makes things pretty smooth. And you'll be doing this quite a bit in your assignment that we're going to explain shortly. So in the normal distribution, everybody should have this up from when we made it earlier, and we can go ahead and answer this question. So it says we want them to be greater than 77 inches tall. So check it out. We're going to use this here. We're calculating the area, and area is probability, by the way. So when you think about probability, you can go ahead and think about area. So let's go ahead and let's use this. So we're going to go, when we say greater than, we're thinking to the right of a value. And that's kind of what I did here, right? We drew the line. We said, okay, we want it to be to the right. It's the red squiggly that's supposed to be shading. But we're going to put 77. Okay. And we're going to go ahead and hit calculate area. And you'll notice that it actually does the shading that I did not do on the left side. And it's in red. And we can click show label on plot. I actually really like that, how it shows it. And by the way, it also includes this notation that we introduced yesterday. So it gives you the area at the bottom here, but it also includes the labels, which I really like. So make sure you have that. And so down here, we don't have to actually use this empirical rule anymore. This technology tool is helping us out quite a bit. And this just happens to be close to 68%. It's not like the 68% rule is here. So, but we're going to say the answer to this is area equals 68.04%. So we will be pretty precise with that. Let's see. So yeah, we have that. And now what you're going to end up doing, like on your assignment, is you'll be snipping. I don't really want to get rid of my snip, but you'll be snipping this and putting it in your answer. Like I would paste it down below this, just to sort of confirm for me when I'm grading it that you had the correct direction and all that. It always helps to have the graph. And so on like tests and stuff, you will use Stapplet to help you get your answers, but it will just be, some of them will be graphs, but it will be super useful for finding the percents or decimal answers for the area or the probabilities. Okay. We have one other thing that I want to discuss. I'm going to go ahead and ask this question here. So this is question 5. Okay, question 5. What height would be the 87th percentile? What height would be the 87th percentile? Now, do we even remember what a percentile is? Let's remind ourselves of the definition of a percentile. So a percentile is the value with p% of the observations less than it. And we did the task within this NBA data to learn about percentiles, and we chose heights. And so we're interested in what value would be the 87th percentile. That's what we're interested in. What height would be the 87th percentile? So that would be to the left is what we're thinking. So if I say to the left and I pick the value, okay, right there. Well, 77, what we just did for question 4 would be the pretty much the 32nd percentile. Okay, because 31.96% is to the left of it. Okay. So, of course, we could just sit in here and we could just type in a bunch of numbers. If we think 87th percentile, well, we already know that within this, what percent of the data is to the middle, A, B, C, and D? Well, that would be the 50th percentile. So the mean is actually the 50th percentile. What would 81.7 be? 81.7, well, we're at 50%, and I go up another 34%. So that is 84th percentile. So this right here is the 84th percentile. So if I did 81.7, look at that, 84%. Okay. Now, we don't actually have to just type numbers in here, because then I could go to 82, that's 86, then there's 83, so on and so forth. But we can actually do, okay, on here for this to get percentiles. So we'll write this to get percentiles in Stapplet, change, and let's look at what this says here. We change the operation here. Okay, we change it to calculate a value to a corresponding area. Okay, so change the operation to, and we'll write this down. So to get a percentile in Stapplet, change the operation to calculate a value corresponding to an area. Okay, so that will make this a lot easier. All we have to do, so calculate a value corresponding to an area, that's up here. So we had this one, calculate an area under the normal curve. You have two options, and so questions like 1 through 4 you can answer with area under the normal curve. But now we're calculating a value corresponding to an area, because a percentile is an area. And so on here we have left tail, right tail, and then you have central, which is just going to be like, if I put 68, 0.68, it gives me the middle 68%, which would be the values that we have on there. That's the 68% rule. So we don't want central. We want, in this case, a percentile is a left tail. So maybe you want to write that down, left tail, on your notes. So left tail. And we get our value by, we'll say left tail, and we put in 0.87. And so there it is. That is the 87th percentile. And here's the value for that. So you can write that down. We're actually going to say so we'll say answer, a height of, what do they give us? 82.104. We'll write it as it is, 82.104 inches. That would be the 87th percentile for height in the NBA for this year. Okay. Now we ask question 6. This is pretty much our last question here, and then we're through with these topics. Okay, so we're almost done here. So we are going to ask this: what heights make up the top 5% of heights? Okay, so what heights make up the top 5%? We know that on here, like if I added these two together, that would be 2.5%. That's what that is, 2.5%. So I can't use those. So we know that it's somewhere in this yellow area F, like that's where it would have to be. But I don't have to guess. I can just change this since it's saying the top 5%. So I've got an area, top 5%, so calculate value corresponding to an area. And so what I can do is I can change this to a right tail, and then just put in 5%. It's as a decimal though, so 0.05, and hit enter. And here it gives me that area 5%, and here's the value. So 83.764 inches. We'll write that. So 80. I've already forgotten the number. 83.764 inches or greater. That's what we're going to say, or greater. Okay, because it's saying what heights. It's not just one height, but it's all the heights that are at or greater than that amount, as we see on here. Now, all these questions you can fully expect to see on the assignment that's coming up. And for all of them, the instruction is going to be include a snip of the of your your answer. So you would be taking little pictures of these and putting them in there, and that's what I'll be looking at as well to confirm your answer. Okay. So for this one, just because we're pretty much wrapping up here, I'll go ahead and show this. I would include just this. This is what I would want to see. Actually, I don't need this. I want the labels on it. So all I would need to see is just this. This tells me everything that I need to know. This shows me that you found the top 5%. This shows me that you have the correct mean and standard deviation, and then it finds that value for you and confirms it. So I would take that and just paste it in to my Word doc, and you can of course edit the size of that as needed. And remember, the copy button is this little, it's like the double pages, or I think you can just press Control-C and it should work. But that's how I do it. So you'll put that in the Word doc. Okay, that concludes the lesson. You can go back and rewatch this anytime. I have a separate video that I will talk about the assignment that's going to go with this.